My name's Callum.
And Miles.
And we like doing things.
What's going on?
Oh my gosh, look at that.
Hear how the sound changes?
Will it become pure water?
I don't know. It's supposed to be what?
I'm just gonna rinse this off so you can hear it change. So it's in the rinse now, and now I'm gonna switch it to something, and you can take a guess at what it
It's
is.
in the rinse.
That's the rinse, correct?
Yes. Is it risk? Yeah, risk.
That is in fact what it is. Good guess.
Yes! I got it.
Alright, so it's in something else now. What do you think it's in?
It's in water.
Pretty close. What have we?
Milk.
Yes, it's in the milk. Alright, let's do one more.
Let's see.
Is it in Sprite?
It is not in Sprite.
Oh, vinegar.
Yep, it's in the vinegar.
Yes.
Cool, you got
We
most
missed.
of those.
Nice job.
Those first times.
So the more soil it has, the more chance there'll be for the soil to affect the water that we're going to pour through it.
What we did is we made a solution that's got about the same pH as acid rain by adding vinegar to the water until we got it to about a 4. And we're going to put it in the dirt water and see what happens. Huh, that's interesting.
Yeah,
Give it some time. Let it
Let it
sit.
sit.
And then you ran it through the soil that has a high clay content, is that right? And the liquid that came out the other end had a pH of,
719.
that's a big difference. What do you think happened?
The acidic, all that acid that was in that mixture we made was absorbed by the soil, and what came out at the end was at about the same pH as pure water.
The Nexus is a integration technology that we've built for Prosperity for All that enables us to connect different things to one another. And in this case, what I have here is I can show you a way that we've been using it for some sensors that you might find in a science lab. Our hope is to be able to use the Nexus to make learning environments like science labs more inclusive. And I'd like to illustrate some recent work that we've done with these sensors. One is to do some visualization of the state of the Nexus, and then the other is to support dynamic configuration of the Nexus as it's running. So what we have is we have 2 sensors currently connected. We have a pH sensor and we have an electrical conductivity sensor. And this, what we're seeing on the screen here, this visualization, is showing the objects that are currently running inside the Nexus. And what I can do is I can expand this section of the components to see the current model value. We have visualizations, sonifications, and other presentations. They can listen to this collected model and then react to sensors to show their values and to allow users to interact with them. And then we have a third component here, in this case called Send pH Sensor. And this one is relating the pH sensor peer model value onto the collector one. And these peers are constructed dynamically depending on what is connected to the Nexus. So for example, if I unplug the pH sensor, then what we will see happen is that the peer for the pH sensor has been removed, and likewise if I unplug the electroconductivity sensor, we see that one has also been removed. And then if I plug them back in again, so we have configured within the Nexus, we have some recipes that say, if this collection of peers is present, then react by constructing this other component. And then whenever that situation is not present anymore, we tear down and we undo the things that we constructed. So that way, whenever we have the collector and then we plug in one of the sensors, we have a rule that says, okay, if there's a collector and there's one of these types of sensors, I'm going to create something that connects them together. And then when that situation changes, the sensor is removed, then we remove the component that did the connecting. So this way we can dynamically react to the addition or removals of peers from the Nexus.